Hello everyone, welcome back to the channel. Today we are going to see how the Z Image Turbo model can generate massive images with incredibly high resolution. Let's look at this final result. The resolution is 8832 by 12192 pixels. It is absolutely loaded with detail. It is actually quite hard to see all the fine details directly inside ComfUI. So let's use a dedicated image viewer to really examine things up close. Now, let me explain how this workflow manages to create such a large image. The first group is simply responsible for the initial image generation using Z Image Turbo. Group 2 and 3 are where the real work happens. They are the heart of this workflow. In the second group, we first split the output from Z image into smaller tiles. Then, we send each piece one by one to Group 3. Group 3 uses CDVR2 for the upscaling process. After that is done, we stitch all the upscaled tiles back together in Group 2. You might be wondering something. CDVR2 handles tiling on its own. So, why are we bothering to split the image manually in Group 2 before sending it to CDVR2? Here is the reason. Before upscaling, the image generated by Z image is already very large. If I try to upscale this image by 2 times directly within CDVR2, I will get an out-of-memory error. Admittedly, CDVR2 does tile the image during the VAE encoding and decoding steps. You can even set the tile size inside this node. But here is the catch. The actual upscaling that happens between encoding and decoding is not done tile by tile. To reduce the video memory used during upscaling, we have 2 options. Option 1 is switching to a smaller model. Option 2 is to enable the Swap I/O Components option and set a proper block-to-swap value. However, even if we use both of those options, we can still run into trouble. If we set a very high resolution here, for example 4096, we will likely still get that out-of-memory error. There is one important thing I need to mention. I spent roughly 20 minutes or so running this workflow on Running Hub. Running Hub is a cloud platform for ComfUI. It comes with all the models and custom nodes pre-installed. The downside is that it does not cache models. CDVR2 relies on cached models to speed up the upscaling process. So if you use CDVR2 on Running Hub, it will be slower than using it locally. If I run this workflow on Running Hub, it only takes about 10 minutes. After upscaling with CDVR2, the image resolution becomes 2943 by 4064. However, her skin does not have much detail yet. That is why in the final group, I use Ultimate SD Upscale for a second pass to enhance the details. So that is the overview of the whole process. Now let's dive deeper into each group so you know how to get the best results from this workflow. Group 1 is straightforward, the basic Z image text-to-image setup. I suggest setting relatively high values for resolutions here. Just make sure neither of them exceeds 2048. These are the samplers and schedulers I am using. You can choose different ones if you like. I already talked about the best samplers and schedulers in a previous video, so I will not go into that right now. Now let's head over to the next group. This group upscales the image by around 2 times. Let's compare the difference before and after. The image has become much clearer and sharper. However, the skin texture is still too smooth. I set the target resolution for the shortest edge to 1024. If you set it to 5036, the skin will have more details, but it will take more time. Since we still have the final group to enhance details, 1024 is enough for this setup. I split the image into a grid, 4 rows and 3 columns. That gives us 12 tiles total. The size of each tile is 1079 by 1117. After scaling them down by a factor of 0.25, the size becomes 270 by 279. Then each tile goes through the third group. There, it will be upscaled around 4 times by SeedVR2. Then each upscaled tile gets resized to 1079 by 1171. We do this so that we can stitch all the tiles back together without causing errors in the image on tile node. If your starting image is landscape shaped, try a 3x4 grid, 3 rows, 4 columns. Or you can use 4 rows and 4 columns for a square image. Then you can tweak the scale by parameter. Try to adjust each tile to around 256 pixels. Then upscale it 4 times to 1024. Now we come to the final group. First, we add some textures to the whole image with a skin deep detail model. This model does not just add skin detail, it adds other details too, like fabric texture. Then I upscale the image by 3 times and pass it to the ultimate SD upscale node. You can also set other upscaling factors like 2. There is actually another version of the ultimate SD upscale node. It allows you to connect an upscale model and set the upscale by parameter directly in the node. However, I found that if I connect the skin deep detail model there, the final image ends up with some artifacts. Keep the denoising strength relatively low here. We only want to add fine textures during this upscale pass, not completely alter the image's underlying structure. For the sampler, I picked Euler Ancestral. It tends to give more polished, refined details compared to other options. Though if you prefer less refined details, other samplers might work better for you. Alright, that wraps it up. If you want to download this workflow, please try our community for free. Christmas is almost here. I hope you all have a wonderful holiday season. A huge thank you to every community member who supports my work. Let's look forward to amazing things together in the new year.